one thing that we've already talked about,
I just watched it
not really doing it today, but, what the?
Hard.
Why is it doing that? There we go. Let's say we have 5, 7, 8. What do we know about this triangle's angles?
The smallest one is across from the side.
Right. Angle B is the small angle. Angle A is the large angle, and C is in the middle.
Do
Okay.
they call them medians?
No. Oh, medium?
Yeah.
It's not a technical word, it's just what I called it.
I don't know. Sorry.
Yeah, so that's from the past. So that's comparing sides and angles inside one triangle. Today we're going to do inside two triangles. But before we do that, we need to talk about something else. If I'm trying to make a triangle, and let's say this is like 5 long and this is 7 long. Well, what do I know about this third side of the triangle?
It's gonna be longest. It's gonna be more than 5 and 7.
Well, depends on how you draw. I could have drawn it like this, 5 and 7, and this one's shorter. But what's something I know for sure about
It's the
this
base.
one? Okay, this third side of the triangle cannot equal 12. It has to be smaller than 12. How do I know that? It has to be smaller than 12. Okay, if you think about it, if I stretch the 5 and the 7 so that they're almost straight, how far could they reach? Okay, if they were completely straight line, it would be a 12 long. So that wouldn't be a triangle though, right?
Yeah.
If the 5 and 7 together make 12. Oh, I said that backwards, didn't I? So this side actually, no, I did that right. Never mind. So the longest they could be is something less than 12. Because together they make 12, but it'd have to be a straight line. So this has to be something less than 12. So 11, yes, that's possible.
13.
13, not possible. It's not possible. So if it was 13, it would be kind of like this. 5, 7, 13. It's not, wouldn't make a triangle. So the rule is the two shorter sides of any two sides in a triangle together have to add up to more than the third side. You guys get that?
Sure.
Any two sides of a triangle have to add up to more than the third side. Or else they wouldn't stretch far enough. So really you just need to usually check the smallest two and make sure they're bigger than the third one. Okay, so that's in one triangle. This next part, the book calls this the hinge theorem. Some books call it side angle side inequality theorem. Okay. So you have to have two equal sides in a triangle, two congruent sides in a triangle. And then you have to know something about the angle between them. Let's say this angle is 35 degrees and this angle is 40 degrees. Then what can be said about these two triangles that they didn't say?
The base is gonna be the same.
Okay, so imagine these two congruent sides, these two are congruent to these two, are like alligator jaws. Okay, this alligator is opening, and they're twins, right? Because they have the same, they're congruent. These two are congruent to these two. But this alligator is only opening his jaws 35 degrees, whereas this alligator is opening his jaws a little bit wider at 40 degrees. then what do we know about these two triangles besides what they told us?
So, on the second triangle, this part is gonna be like longer.
Okay. You said on the second triangle over here, this was gonna be bigger than this one.
Right.
How did he know that?
Because it's going out wider.
Yes. So if this alligator, which is a twin to this alligator, is opening his mouth a few degrees wider, then the gap between his jaws has to be a little bit bigger than the gap between this alligators. Does that make sense?
Yeah.
It's called the hinge theorem. And you can do it backwards. This is the converse of the hinge theorem. So on this one, see if I can match it again. So the jaws are the same again. So these two match these two. But this time we know, like, this is, let's see which one looks bigger. We'll say this one is like 10 and this one's like 12. Well, by the way, I probably should have written this. BC is smaller than EF. That's from the last one. That's kind of like the answer. So on this one, what do we know about these two triangles?
So the angles are like 12 angle is bigger and
Right.
Angle A will be bigger than angle B.
Yeah, it's the same thing but backwards. So this alligator must have his jaws open at a wider angle because it opens up to a 12, whereas his twin only opens up to a 10. So angle B is less than angle A, or angle A is greater than angle B. Yeah, they call that, our book calls it the converse of the hinge theorem. You guys know what a hinge is?
Like a door hinge?
It's these things that the door turns on. You know, these silver things. Because, like, when you open the door, it, like, creates an angle right there. And the angle turns. So, it depends on how wide that's, like kind of like the hinge in your jaw, how wide it's open to how big this side over here is. Anyways, okay. Does that make sense? So, we got kind of two things. Two sides in a triangle have to be greater than the third side of the triangle. And then the two alligator jaw things, the book calls it hinge theorem. Okay, number one. Let's jump in.
Number one.
Attempt to sketch triangle ABC with the given side lengths. Either classify the triangle by its side length, identify the point that lies between the other 2 points, we're not going to do that, or state the segments do not meet. So what happens when we try to draw this? 4, 7, and 5. Okay, maybe something like this. Yeah. So it's like A, B, C. Now, is that a possible triangle? Yeah. The two smaller sides together, 4 and 5, are bigger than the other side together. 4 plus 5 is bigger than 7. So it is possible to have that triangle. So in this case, we're just supposed to say what kind of triangle it is based on the sides. Scalene. Haven't forgotten it in a week and a half.
I forgot it.
One person hasn't forgotten it.
I forgot.
It's hard to forget something you never knew. Okay. Number 3. Okay, this one has a 5, a 5, and a 10. What's the problem with that?
It's going to create a straight line.
Yeah, so 5 and 5 are just long enough to reach 10, so they can't make a triangle. So on this case, we're just going to put, it makes a line, not a triangle. So if 5 plus 5 equals 10, that's not going to make a triangle. So not long enough. Number 5, 1, 3, and 5. Is this possible? Make a triangle?
Yeah.
No. and 3 together cannot reach the 5. So I'm just going to put not possible. The book wrote segments don't meet. I like my answer better.
It just gets right to the
So these are kind of the 3 options for, well, it's not necessarily scaling, but the kind of triangle that it becomes, it makes a straight line, or it's not possible. It's not possible because 1 plus 3 is too small for 5.
What's it? What is the SSS triangle? Side triangle. What's it called again? Like
All 3, no, SSS is to prove 2 different triangles
sorry,
are
what's like-
congruent.
Like
All equal sides,
Yeah.
equilateral. Okay, number 7. State whether attempting to construct triangle ABC with the given side lengths would produce a triangle, collinear points, which means points in a line, or segments that don't meet. So it's kind of the same thing as before, except for they're not asking us to draw it this time. So on number 7, 8, 4, and 12. What would that make if you tried to make a triangle out of those sides?
It'd be a line.
Yeah. 8 and 4 together can only reach 12, so it'd be like a straight line. Not to triangle. Let's put line. Oh, they put collinear points, didn't they? I'll go ahead and write that. That's an okay answer by my book.
you need to put those numbers.
I was just copying what they wrote. Number 9, 8, 7, and 4. Is that possible?
No.
4 plus 7
11.
is greater than 8. So yeah, it's possible. 8 plus 7 is greater than 4. The two have to be bigger than the third together. Any two sides have to be bigger than third. So if you just check the 2 smaller ones, 7 and 4, is that greater than 8? Yes. So that actually could make a triangle.
Wait. Wait, don't you have to add them together though? Like, I'm confused on how 9 is a triangle again.
Okay, 4 and 7 together have to be bigger than 8 because they have to reach across the 8.
Oh.
Any 2
Oh, yeah,
sides
right.
together have to be greater, not less than. Anyways, is it possible to make a triangle with 50, 50, and 101? No.
Yeah.
No, it's not possible. They put segments don't meet. I'm just gonna put not possible again. 50 and 50 are not even long enough to make a straight line.
Mr. Jordan.
Yeah.
So I never really get to draw like you have to draw the pictures of the line and whatnot. So can you go up so that I can yeah. I didn't know.
Whitley, I just realized there's some drawings. Are you keeping up with this?
Yes, I'm doing so good. I'm doing really good.
Whitley's on number 2. Or number 3.
How do you know I was literally going to start working out?
I meant you. Never mind. Okay. Should have said number 3. Okay, 13. Use the hinge theorem or its converse. So hinge theorem translates to alligator mouths. So what you kind of have to do is locate the 2 sides that are identical in both triangles, and those are going to be the mouths. So on this one, the 4 and the 7 are the identical mouths. Where did I put a 5 right there? Oh, it's a 50-degree angle, that's why. Okay, and over on this one, it's kind of like that. Okay, so there's the alligators. Something like that. Okay, this one is a 50-degree angle and the other one is only 30 over here. So what can we conclude?
That the
first
If you
triangle's
go
bigger.
first
Okay,
on,
this, since this alligator's mouth is open wider, I probably didn't draw very well, but if he's open wider than this one, then this gap between his jaws should be bigger than the gap between this jaw, these jaws. So this is bigger than that.
So WJ is bigger than BE.
Yeah, so WJ is greater than BE. Why didn't I put a segment symbol on top?
Because it's
because
the
it's
size.
not.
Because we're talking about the length of the segment, so you don't have to draw it. Okay, 15, kind of the same thing. It's a little bit tricky because there's two right angles, but they're in different spots. So we got a 3 and a 5 on both of these. But, so, this would be the jaws on the right one. Guess I'll put the eyeball right there. And this would be the jaws on the left one. Okay, well, how many degrees is this jaw open? 90. How many degrees is this jaw open?
90.
No.
That's a good question.
This is 90. What do I know about this? No, not 45, but something less than 90. These two together have to add up to 90 if this one is 90. Right? So this has to be less than 90. And this one is 90. So that means this guy's open wire. So big, small.
So, AC,
AC is greater than PR.
wait. Okay. Air conditioning is better than personal record.
PR, personal relations.
Record. It's personal record.
Okay, number 19. So we got this drawing on number 19.
Right.
It goes A, B, C, D. Well, what do I know, before they tell me anything, what do I know about these, what's something I know about these two triangles?
B and D are the same.
BD is congruent in both triangles. So they already got like one shared jaw, like right there. Okay, number 19 says compare angle ABD and BDC. So ABD, that'd be this one right there, and BDC.
Yeah.
BDC, that's this one down. Okay, so we're supposed to figure out who's bigger or if they're equal or whatever. AB is 9, BC is 8. AD is 6, DC is 9. Okay, so kind of job number 1 is locate the twin alligators, the jaws. Well, since this is a shared side, that'd be one of them. And they also both have a 9. So the jaws are going to be the 9 and this side. The 9 and this side.
How'd you know it was a 9?
Because you're looking for the twins, so they both have a 9 and they both have this. Which makes sense because we're supposed to figure out these angles.
So the jaws go where the angles are supposed to be? Like, the angles?
Well, I kind of, it's not a coincidence that happened, but okay. So this alligator opens up to an 8. This alligator, who's the exact same size, 9 and this, opens up to a 6. So what can I say then?
D is bigger.
BC is greater than AD.
No.
D
It's got it. So, there's nothing I can say about the sides. We know what all the sides are already. But this alligator opens up to an 8. That means his angle that he's opening his jaw must be larger. Now, it's possible you could have one alligator who's opening his jaws really wide, but it's still not going to be bigger than the gap between another alligator because he's a. So it's important that the alligator's jaws are the same size before this trick works. If the alligator's jaws are the same size, then fix it. Then that gap tells you something about the angle or vice versa. So this is a bigger gap, so this is a bigger angle. This is a smaller gap, so this is a smaller angle. So it says angle ABD and angle BDC. So this one, it mentions first compared to this one. So this is less than that. So anyway, the answer is less than. Alright, let's see if I can get rid of all this garbage. Don't need that, don't need that. Put so many angle symbols in there. Okay. 21 says we're gonna compare AD and DC, the sides on the bottom. AB is 16, BC is 16. And angle ABD right there is 1/2 of angle ABC. So what does that tell me? If this angle is half of angle ABC, what does that tell me?
It tells you that the AB.
Okay, let me say it again. Is everybody listening? It says angle ABD, this angle right here, is 1/2 of angle ABC.
It tells you that it's congruent.
Yeah.
Right. If this is half of the big angle, then the two little angles must both be a half.
Yeah, agree.
So those two are the same. So it's asking us to compare AD and DC.
Oh, they're the same.
Yes. So these triangles are actually congruent. You know how I can tell? Side, angle, side. So that means, what do I know about AD and DC?
They're the same.
Equal in length.
Is 26 an even number or an odd number?
Really? If it ends in 0, 2, 4, 6, or 8, it's even.
I know.
And why do you ask?
But why are we doing 26? Like, why?
Why?
Yeah, because it's not helping us. Are you helping us with 26?
Please, Mr. Roden.
Why? How do you know? We could just end it at 25.
Police! Yappa, yappa, yappa. Police! We won't even have an example. What? Are you doing there?
Contemplating beating you with a yardstick.
Honestly,
Okay, on 23, it's basically saying that we have two sides of a triangle, 3 and 36, and what is the range of possible lengths that the third side could be? Okay, well, you guys know what the third side could be?
Nope.
has to be greater, less than.
Okay.
Yeah.
It would have to be smaller than 39.
Yeah.
You guys know why?
Because that's what they add up to.
Because these two together could stretch to 39, but they wouldn't make a triangle. So it has to be smaller than 39. Also, though, it has to be bigger than, okay, this guy, 3, and some other side need to be bigger than 36. So it also has to be bigger than 33. Because 3 and 33 together make 36, so this one has to be bigger than 33. So,
Wait.
It could not, the third side could not be 33 because these two together are not bigger than 36.
Facts.
So it has to be bigger than 33. So here's the way to write it. X has to be greater than 33 and smaller than 39.
Weird.
Yes. Now, let's see if we can find a pattern. Where did this 33 come from? Well, basically 33 is the difference between the big and the small one. And that kind of tells us X has to be bigger than that. How about the 39? 39 is like the sum of these two, and X has to be smaller than that.
It's a pattern.
Pat,
That's what my cousin called it.
I guess they use 3 syllables somehow.
Pattern.
Pattern.
You're speaking of the ruler again.
I know what 25 is.
Anytime I feel like beating a child. Just kidding. Edit that
Will
off
we
video.
go first? I know, right?
I was just,
Yeah, go for it.
well, actually, I was remembering when my younger brother was little, he would try to say specifically, but he would say pacifically.
That is a hard word though, when you think about it.
Oh, I used to say penguins as penines.
Oh.
Super weird, but it was penines.
Yeah, it was like last year.
No, he still messes it up.
He's like, P9s live in the South Pole. And everybody's like, what? Okay, 25, we got A and a B.
X, can I say it? X is greater than, or less than A plus B.
Okay, it's gotta be less than the sum,
And
but it's gotta be
greater than.
greater than the difference.
Yeah.
Here's the thing though, how do I know which is bigger, A or B?
You don't.
You don't. So to make sure it comes out positive, you can put absolute values right there.
Oh, is this gonna be on the test?
Absolutely.
This isn't
23.
even bad.
23 probably will be on the test, so.
This isn't even that hard.
Uh-oh.
Jordan, you forgot how
Let's not
do-
let's just stop at 20. No, that's Timmy. That's all
Yeah.
we really hear. That's all we
That's
really hear.
facts.
That's all we really hear. That's Timmy.
Okay, on 26, do you guys see the 2 alligator mouths?
Yes.
They're kind of clear because they marked them with the red.
40 and 75.
Okay, the alligator on the left is open 40 degrees, the alligator on the right is open 75. So what do I know?
That ED triangle EDF is bigger than.
No, not triangle.
You guys are talking.
Okay,
Oh,
EF has to be
bigger.
bigger
Than BC.
than BC. So in other words, X plus
Because-
5
Because is smaller than.
is greater than 2x minus 2. Okay, how do you solve inequalities? The same way you solve equations. Just get x by itself on one side. So what do we need to do?
Minus X.
Minus x.
I do remember that because my fingers still hurt the next day.
Plus 2. Ooh, you're doing so good. Thank you. You're doing it kindly. That's gonna be
What are you quoting when you say?
the Kardashians. She's like pushing a shopping cart and like putting it back, and her mom's like, "You're doing amazing, sweetie." Because she's doing like a normal person.
You guys watch the Kardashians?
No, I just see
Shame,
pictures.
shame.
No. I watch the dance.
Shame them.
Yeah.
My fingers like